Right now, as you sit reading these words, a frozen world 500 million miles away is actively stretching its icy body in the dark. Deep beneath a solid crust of blinding white ice, millions of trillions of gallons of salty water are surging through complete darkness. A giant global liquid ocean is moving right now beneath a frozen shell, holding more water than every single sea on Earth combined. For decades, scientists thought this distant sphere was just a dead, frozen rock drifting through deep space. But brand new discoveries have just proven that this mysterious world has every single ingredient needed for living creatures. If you're fascinated by the real secrets of our universe explained in simple, clear language, take a quick moment to hit the subscribe button right now. Joining our channel means you will always stay ahead of the curve as humanity uncovers new worlds and searches for alien life across deep space. We bring you authentic science stories every single week without any exaggerated claims, so subscribe today and become part of our growing community of curious mind explorers. To understand why this tiny world is driving planetary scientists crazy with excitement, we have to travel back in time to where the story first began. More than 400 years ago, in the year 1610, an Italian astronomer named Galileo Galilei built a small wooden telescope and pointed it toward the night sky. He aimed his glass lens at Jupiter, the grandest and heaviest planet in our solar system, and spotted 4 faint dots of light hanging around it. Those 4 tiny pinpricks of light were the very first moons ever discovered orbiting a world other than planet Earth. And one of those 4 tiny specks of light was a moon named Europa. For nearly 4 centuries after Galileo first saw it, astronomers could learn very little about Europa because it was so small and so far away. Through even the largest ground telescopes on Earth, Europa looked like nothing more than a featureless, blurry dot of yellow light. Nobody knew what its surface looked like, what its interior was made of, or whether it was anything more than a cold, forgotten chunk of space gravel. Everything changed in the late 1970s when NASA launched 2 famous robotic space probes named Voyager 1 and Voyager 2. These twin probes were designed to fly past the outer planets and take the very first detailed photographs of distant worlds. As the Voyager probes swept past Jupiter, they pointed their specialized cameras at Europa and transmitted clear images back to scientists waiting on Earth. When researchers received those first pictures, they were completely stunned by what they saw on their screens. Scientists had expected Europa to be heavily battered and covered in dark craters, much like our own moon or the planet Mercury. Most old worlds in our solar system are covered with thousands of deep scars left behind by asteroid and comet impacts over billions of years. But Europa looked completely different from any world humans had ever seen before. Its surface was bright, brilliant white, incredibly smooth, and crisscrossed by thousands of dark reddish-brown lines that stretched for thousands of miles across its face. It looked like a giant glass marble that had been dropped onto a hard floor and cracked all over its surface, but somehow remained held together. Even more surprising was the complete absence of large impact craters. Out of the millions of meteorites that must have struck Europa over its long history, almost no visible marks remained on its white skin. When a celestial body has no craters, it tells geologists that something active is constantly erasing the scars and renewing the surface layer. On our own planet Earth, wind, falling rain, flowing rivers, moving glaciers, and erupting volcanoes constantly wear down old landforms and hide ancient impact craters. But Europa has no thick air, no weather system, no wind, no rain to wipe away its scars. So what was hiding the crater marks on Europa? Scientists began to suspect that the outer crust of Europa was made of pure water ice, and that this ice was breaking, shifting, and freezing back together over time, behaving like a floating ice sheet on Earth. To test this wild theory, NASA developed a dedicated spacecraft named Galileo, named in honor of the famous astronomer who first saw the moon. In the mid-1990s, the Galileo spacecraft arrived in orbit around Jupiter and spent several years making close flybys of Europa. It flew just a few hundred miles above the white ice, taking razor-sharp photographs and measuring the physical forces surrounding the moon. The information returned by the Galileo probe changed our view of the solar system forever. The most important breakthrough came from the spacecraft's magnetic sensors. As Europa traveled through the powerful magnetic field surrounding giant Jupiter, the sensors picked up a secondary magnetic field coming from inside Europa itself. The only way Europa could generate its own magnetic response was if it contained a thick, continuous layer of material that conducts electricity deep under its frozen crust. The most common natural substance in space that can conduct electrical currents across an entire moon is salty liquid water. When mathematical scientists calculated the strength of that magnetic signal, they realized something that sounded like science fiction. Beneath a solid outer crust of hard water ice about 10 to 15 miles thick, Europa conceals a massive global ocean of liquid water. This hidden sea is not a small underground lake or a collection of isolated puddles. It is a continuous planetary ocean that covers the entire moon from pole to pole and is estimated to be between 40 and 80 miles deep. To help you understand how deep that really is, consider the deepest part of Earth's ocean, the Mariana Trench in the Pacific Ocean, which reaches down about 7 miles. Europa's ocean is up to 10 times deeper than any ocean on Earth. Even though Europa is a relatively small moon, roughly the same size as Earth's moon, its hidden sea holds more than twice the total volume of all liquid water found on Earth combined. Finding that much water on a small world far from the sun was one of the greatest discoveries in the history of science. However, as exciting as it was to find a giant ocean, space scientists knew that liquid water by itself is not enough to support living creatures. If you want to find life on another world, even simple microscopic life like bacteria, 3 primary ingredients must be present at the same time. First, you need liquid water to serve as a liquid environment where biological molecules can move and react. Second, you need specific chemical building blocks like carbon, oxygen, nitrogen, phosphorus, and sulfur. Third, you need a steady source of energy to power living cells. For many years, astrobiologists worried that Europa possessed only the first ingredient. After all, Europa orbits Jupiter at a distance of more than 500 million miles from the Sun. That is 5 times farther away from the Sun than Earth is. Because of that great distance, the sunlight reaching Europa is 25 times weaker than the warm sunlight we feel on Earth every day. At the surface of Europa, the temperature never gets warmer than minus 260 degrees Fahrenheit, and near its poles, it drops to minus 370 degrees. At such freezing temperatures, ice becomes as hard as solid granite rock. So how could an ocean of liquid water exist beneath such a freezing wasteland without turning into solid ice all the way down to the bottom? The answer to this mystery comes from a powerful gravitational process called tidal flexing. Europa does not orbit Jupiter in a perfect circle, and it is not alone in its neighborhood. It travels along an oval path while interacting with 2 other large sister moons named Io and Ganymede. As Europa moves along its orbit, the immense gravitational pull of giant Jupiter tugs on it with changing strength, while the nearby moons pull on it from the opposite side. This endless gravitational tug-of-war stretches, squeezes, and flexes Europa's rocky core like a rubber ball being continuously squeezed in a strong hand. All of that internal stretching creates immense friction deep inside the moon, producing enormous amounts of heat. That heat rises from the rocky interior, warming the bottom of the ocean and keeping the deep water liquid despite the freezing cold of space above. Did you know that deep at the bottom of Earth's ocean, far beyond where any sunlight can reach, thriving communities of strange sea creatures live around hot volcanic vents? If you find it amazing that life can flourish in total darkness, hit the like button right now and leave a comment telling us if you think alien life exists in Europa's dark sea. Make sure to subscribe as well, so you never miss any of our deep space science stories as they come out. On our own planet Earth, hydrothermal vents spew scalding hot water loaded with rich minerals into the pitch-black ocean floor. Around these glowing underwater chimneys, blind shrimp, giant red tube worms, and trillions of microbes form entire ecosystems without ever needing sunlight. Instead of using light energy like plants do on land, these deep-sea creatures use a chemical process called chemosynthesis, converting volcanic chemicals directly into living energy. For decades, scientists wondered if Europa's seafloor had similar hydrothermal vents, providing energy for living organisms in its dark ocean. While having a warm ocean powered by internal heat was a huge step forward, scientists were still searching for the second major requirement for life: essential chemical elements, especially carbon. Carbon is the foundational building block for every single living thing on Earth. Carbon atoms have a special ability to link together into long, complex chemical chains that form cell walls, genetic codes, proteins, and enzymes. Without carbon, life as we know it simply cannot exist. For a long time, nobody knew if Europa had any carbon, or if its ocean was just plain, dead salt water wrapped around a dry rock. Detecting small chemical elements on a frozen moon hundreds of millions of miles away is a giant technical challenge. Astronomers had to wait for space technology to advance to a level where they could analyze the light bouncing off Europa's surface with incredible accuracy. That technological breakthrough finally arrived when NASA deployed the James Webb Space Telescope, the most complex and powerful observatory ever built by human hands. In late 2023, scientists pointed this giant space telescope directly at Europa to read its surface chemistry using advanced infrared sensors. What the James Webb Space Telescope detected surprised even the most optimistic astronomers on the research team. The telescope identified a clear, sharp chemical signature of carbon dioxide ice sitting directly on Europa's frozen crust. Carbon dioxide is a simple molecule made of one carbon atom attached to 2 oxygen atoms. Finding carbon dioxide on an icy world is always exciting, but the exact location where this carbon was found made the discovery truly historic and game-changing. The carbon dioxide was not scattered randomly across Europa, nor was it found in areas where old meteorites had crashed in the past. Instead, the highest concentrations of carbon dioxide were located in a specific region known as Tara Regio. Tara Regio is a prime example of what planetary geologists call chaos terrain. Chaos terrain is a messy, broken area where the icy skin of Europa has been disrupted, melted, and reshaped by warm ocean water rising up from the dark depths below. In these chaos terrain regions, giant blocks of surface ice appear to have cracked apart, drifted around, and frozen back together in a scrambled pattern. Warm liquid water or slushy ice from the subsurface ocean worked its way upward through deep cracks in the crust, spilling onto the surface before freezing instantly in space. The fact that carbon dioxide is heavily concentrated right inside this freshly resurfaced chaos terrain points to one unavoidable conclusion. The carbon did not fall from space on comets, but came directly from the liquid ocean hidden deep underneath the ice shell. Let us pause and really reflect on what this breakthrough discovery actually means for the search for alien life. The carbon sitting on the surface of Europa was carried up from the liquid ocean below, proving that Europa's hidden sea contains a rich supply of carbon, the ultimate structural building block for living things. Scientists calculated that this carbon was deposited on the surface relatively recently in geological terms, showing that the ocean is actively exchanging chemical materials with its surface layer on a regular basis. Here's another astonishing detail that researchers uncovered when analyzing the light data from the James Webb Telescope. The carbon dioxide molecules inside the Tara Regio region are chemically fresh and undamaged. If that carbon had been sitting exposed on the surface for millions of years, the harsh radiation surrounding Jupiter would have broken those chemical bonds apart long ago. Giant Jupiter possesses a massive magnetic field that traps high-energy particles, blasting Europa with intense radiation every single day. The fact that the carbon molecules are still intact proves they were pushed up from the ocean very recently. This continuous exchange of physical matter between the deep ocean and the outer ice surface is crucial for sustaining living organisms. On Earth, our oceans stay healthy because they constantly interact with the air and land, recycling nutrients, gases, and minerals in a continuous loop. If Europa's ocean were completely sealed off from the outside world by an unbreakable wall of ice, it would eventually run out of fresh chemical energy and become a dead, stagnant sea. But the existence of chaos terrain proves that Europa's crust is dynamic and active, breathing chemical elements back and forth like a living planetary engine. Have you ever wondered what it would look like to stand on the edge of a giant crack on Europa while warm ocean water erupts out into space? If that mental picture gives you chills, drop a comment below telling us what you think alien life on Europa might look like. Do not forget to hit the subscribe button right now so you never miss another thrilling episode about our solar system's greatest mysteries. While carbon serves as the basic structural skeleton for living cells, biological organisms also require several other key chemical elements to function properly. Oxygen, sulfur, and phosphorus play major roles in storing cellular energy and building genetic structures inside living tissues. For a long time, researchers were unsure if Europa had access to a steady supply of oxygen. Because Europa has no green plants or sunlight to power photosynthesis, where could a steady supply of oxygen possibly come from on such a frozen, sunless moon? The answer to this puzzle lies in the harsh radiation environment created by giant Jupiter. As high-energy particles from Jupiter's magnetic field strike Europa's icy surface, they smash into water ice molecules and split them apart into their basic elements. This radiation process breaks the water molecules into separate hydrogen and oxygen atoms. The lightweight hydrogen gas quickly escapes into the vacuum of space, while the heavier oxygen atoms remain trapped within the frozen surface ice. For many years, scientists debated whether this surface oxygen could ever travel down through miles of hard ice to reach the ocean underneath. Advanced computer models and geological studies now show that when heavy slabs of surface ice sink during chaos shifting events or when dense saltwater channels form inside the ice shell, surface oxygen gets drawn downward into the liquid water. This transport mechanism delivers a continuous supply of oxygen directly into the ocean, acting like a massive chemical battery that fuels the water below. In early 2024, NASA's Juno spacecraft performed an ultra-close flyby of Europa, passing within 200 miles of its icy surface to measure the exact rate at which oxygen is being generated today. Juno's sensitive instruments revealed that Europa's surface produces roughly 24 pounds of pure oxygen every single second. That is enough oxygen to keep over 1 million human beings breathing every single day, while this generation rate was lower than older theoretical estimates. It confirmed beyond any doubt that fresh oxygen is constantly created and available at the surface shell. When you mix fresh oxygen from the surface with rich carbon and raw minerals from the rocky ocean floor, you create an incredible chemical broth. On Earth, When oxygen-rich water interacts with mineral-heavy underwater hydrothermal vents, it creates the exact conditions where primitive life first emerged billions of years ago. Many leading astrobiologists now believe that the floor of Europa's ocean may closely mirror the ancient hydrothermal conditions of early Earth, offering a perfect cradle for simple life forms to take hold and survive. Think about how remarkable that realization is for a moment. For centuries, human thinkers assumed that life could only exist on planets that sit at a comfortable distance from their parent star, within what scientists call the habitable zone. We believed a world needed to be warm, have open oceans under a sunny sky, and enjoy mild seasons to support life. Europa completely shatters that old assumption. It proves that massive liquid oceans can flourish far beyond the conventional habitable zone, kept warm from within by gravitational energy rather than sunlight. If Europa can sustain a warm, liquid ocean packed with carbon, oxygen, and energy, billions of miles from the sun, then subsurface oceans might be the most common habitat for life across the universe. There could be thousands of icy moons hiding vast liquid seas beneath frozen crusts within our galaxy alone. Life might not be a rare planetary miracle, limited to warm surface worlds like Earth, but a widespread phenomenon occurring inside dark, frozen worlds scattered across the cosmos. What do you think is the most mind-blowing fact about Europa so far? Its massive global ocean, its internal tidal heating, or its rich carbon chemistry? Post your answer in the comments below, and remember to hit that subscribe button right now to stay connected with our growing community of space enthusiasts. Now, let us turn our attention to what is happening right now in the world of space exploration. Humanity is no longer just looking at Europa through ground telescopes or distant space photos. We are actively executing historic missions designed to travel directly to this icy world and inspect its ocean system up close. As you read these words, 2 sophisticated space missions are traveling through deep space, heading straight toward Jupiter and its family of ocean moons. The first mission is ESA's European Space Agency probe named JUICE, which stands for the Jupiter Icy Moons Explorer. Launched in April 2023, JUICE is currently executing a series of complex gravity-assist flybys around Earth and Venus to gain the extreme speed necessary to reach Jupiter by 2031. JUICE will conduct detailed flybys of Europa, Callisto, and Ganymede, using ice-penetrating radar to look deep beneath their frozen crusts and create detailed maps of their hidden water layers. The second and most direct mission is NASA's flagship spacecraft named Europa Clipper. Europa Clipper was engineered with one primary goal: to determine if Europa has conditions suitable to support alien life. Packed with 9 cutting-edge instruments, including ice-penetrating radar, infrared thermal cameras, mass spectrometers, and magnetic sensors, Europa Clipper will perform nearly 50 ultra-close flybys of Europa, dipping as low as 16 miles above the frozen surface. While Europa Clipper will not land on the ice, it will execute a maneuver that is just as thrilling. It will fly directly through Europa's thin atmosphere to collect and analyze particles floating in space. Astronomers have spotted evidence suggesting that giant plumes of ocean water occasionally blast through cracks in Europa's ice, shooting water vapor and ocean salts dozens of miles into space. If Europa Clipper flies through one of these active plumes, its instruments will capture and analyze raw ocean water in real time without ever needing to drill through miles of solid ice. The instruments aboard Europa Clipper will scan the ice surface for complex organic molecules, measure the precise thickness of the ice shell, and determine the exact saltiness and depth of the ocean below. By carefully measuring how Europa distorts Jupiter's magnetic field, scientists will be able to confirm whether the liquid ocean rests directly on top of a rocky seabed. That detail is critical because an ocean touching a rocky seafloor can exchange heat and minerals, creating a dynamic environment capable of supporting biological chemistry. Here is a specific technological detail that space researchers are particularly excited about. Europa Clipper carries a state-of-the-art thermal imaging system called e-THEMIS. This infrared camera will scan Europa's surface to search for warm anomalies where internal thermal energy is leaking out through cracks. If warm water or slush is rising near the surface, e-THEMIS will spot it immediately as a bright glow in infrared light, showing future space missions exactly where to land a probe to drill down into the ice. Imagine the incredible reality of what these twin space missions could uncover over the next decade. We could receive definitive chemical proof that complex organic compounds, biological building blocks, or cellular chemical signatures exist inside Europa's water. We may discover that Europa's hidden ocean has remained stable, warm, and rich in vital nutrients for over 4 billion years, giving potential life forms more than enough time to originate, adapt, and evolve in the dark depths. If NASA's Europa Clipper spacecraft captures water vapor from an erupting plume, do you think it will detect signs of organic chemistry right away? Leave a comment below with your predictions, and make sure to subscribe to the channel so you can follow all the incoming space mission updates as they happen. To fully understand why these discoveries matter so much, we have to look beyond the raw numbers, chemical formulas, and space engineering. Finding life on Europa, even if it consists of simple microscopic bacteria, would transform human history and our understanding of reality forever. Right now, science only knows of one single example of life in the entire cosmos: the living organisms found here on planet Earth. Every plant, animal, and single-celled microbe on Earth shares the same fundamental genetic blueprint and chemical foundation. Because we only have our own planet as an example, scientists cannot be certain whether life on Earth is an astonishingly rare cosmic accident or a natural consequence of physics and chemistry. If we discover a second, completely independent origin of life on Europa, it will prove, once and for all, that life is not a unique miracle reserved for Earth. It will show that life is a natural feature of the universe, emerging wherever water, organic chemistry, and energy come together in harmony. Think about how profound that shift in human perspective truly is. For thousands of years, humans believed Earth was the absolute center of everything. Modern astronomy eventually showed us that Earth is just one small planet, orbiting a common star among hundreds of billions of stars in our galaxy. Yet, many people still feel that living creatures might be completely unique to Earth, leaving us isolated in a vast, empty universe. Discovering living cells inside a frozen moon in our own solar system would answer that ancient human question with absolute certainty. We are not alone. Europa represents an entirely different class of living world compared to Earth. On our planet, life is powered by sunlight, flourishing across a bright surface beneath an open atmosphere. On Europa, if life exists, it thrives in complete perpetual darkness, sheltered beneath miles of solid ice and powered by gravitational friction and deep underwater volcanoes. It proves that a world does not need warm sunshine or blue skies to foster living systems, expanding our search for alien worlds to every corner of the universe. As we stand on the doorstep of these monumental scientific breakthroughs, the coming years promise to be the most thrilling era in the history of space exploration. Spacecraft are currently speeding through deep space, powerful telescopes are scanning frozen worlds, and scientists are assembling the final pieces of an ancient cosmic puzzle. Europa is no longer just a cold, distant speck of light in a telescope. It is a dynamic world holding answers that could change our understanding of life forever. The realization that an ocean world 500 million miles away holds water, carbon, oxygen, and heat should inspire every single one of us. It reminds us that our universe is overflowing with wonder, waiting for curious minds to ask questions and push the boundaries of knowledge. The journey to explore Europa is not just about space probes and chemical graphs. It is about human curiosity reaching out into the dark to discover our place among the stars. The search for extraterrestrial life has always been the ultimate quest for human explorers, but we always expected to find it on a world that looked a little bit like our own. We searched for planets that orbited at a comfortable distance from warm stars, hoping to see blue skies, white clouds, and green continents. We spent decades listening to the static of deep space, hoping to hear a radio signal from a distant civilization that lived just like we do. Europa forces us to completely reimagine what a living world can be. It tells us that life does not need a sunny day or a sandy beach to get started. It shows us that life is tough, adaptable, and capable of finding a way to survive in the most extreme and unexpected environments imaginable. The universe is likely filled with frozen, icy moons just like Europa, each one hiding a warm, dark ocean rich in chemical potential. If life can take root in the total darkness of Europa's subsurface sea, then our galaxy must be teeming with biological activity. It means that the universe is not a barren, sterile wasteland, but a vast ocean of possibilities where life is constantly struggling to emerge in the shadows. This one tiny moon orbiting Jupiter has given humanity the greatest hope we have ever had of finally proving that we share this grand universe with other living things. As we wait for Europa Clipper to reach its destination and beam back the first hard evidence of what lies beneath the ice, we can only imagine the strange and wonderful chemistry happening right now in the deep. Scientists are working around the clock to build new models of Europa's ocean floor, predicting how volcanic vents might look and function under such incredible water pressure. Engineers are already dreaming up future missions, sketching designs for submarine probes that could one day melt through the ice shell and swim free in the alien water. These future submarines would need to be entirely autonomous, equipped with artificial intelligence to navigate the pitch-black waters without direct human control. They would use sonar pulses to map the rocky seabed, chemical sniffers to track down organic molecules, and bright floodlights to illuminate a world that has never seen a single ray of light in 4 billion years. The challenges of building such a machine are immense, but the potential rewards are beyond anything humanity has ever achieved. Every piece of data we gather today brings us one step closer to that ultimate dream of sending a swimming robot into an alien ocean. The discoveries made by Galileo, the stunning chemical maps drawn by the James Webb Space Telescope, And the oxygen measurements taken by Juno are all vital stepping stones on this incredible journey. We are piecing together the puzzle of Europa layer by layer, from its smooth icy surface down to its hidden rocky core. The story of Europa is a testament to the power of human curiosity and our relentless drive to understand the universe around us. We started by looking at a blurry dot through a wooden tube, and today we are sending robotic laboratories across hundreds of millions of miles of empty space to taste the water erupting from an alien sea. We are a species that refuses to stop asking questions, and Europa is giving us some of the most exciting answers we have ever found. Thank you so much for exploring the mysteries of deep space with us today. If you enjoyed this video and learned something new about our incredible universe, please support our channel by clicking the subscribe button, hitting the like button, and turning on all notifications so you never miss a new story. Before you go, drop a comment below answering this question. If humanity builds a submarine probe to explore Europa's ocean, what do you think it will discover first? Share this video with anyone who loves space, science, and the great secrets of the cosmos, and we will see you in the next investigation.